Have you ever wondered how vital instrumentation devices are in facilitating the complex processes in various industries? To operate efficiently and safely, industries such as manufacturing, oil and gas, or pharmaceuticals rely heavily on these clever pieces of technology. Instrumentation devices are the unsung heroes, monitoring and controlling process conditions like temperature, pressure, and flow. Imagine a symphony orchestra. In the same way a conductor brings together the harmonious play of various instruments to create a beautiful symphony, these devices coordinate and control complex industrial processes. They ensure everything is in harmony, from the heat of a furnace in a steel plant to the pressure in an oil pipeline, or the flow rate in a pharmaceutical lab. Without these devices, we wouldn't have the level of precision and safety required in today's high-tech industrial world. They are the eyes and ears of engineers, enabling them to make informed decisions and keep processes running smoothly. Let's delve deeper into each of these intriguing devices and understand their individual functions. Flow meters, as their name suggests, measure the flow of liquid or gas. These ingenious devices are crucial in a multitude of industries, tracking the flow rate or quantity of a gas or liquid as it moves through a pipeline. Now, you might be wondering, how do they do that? Well, that's where things get interesting. Picture a river. How do we measure the flow of water? We could toss in a floating object and time how long it takes to travel a set distance. This gives us a basic idea of flow rate. Flow meters, in essence, work in a similar way, but with a lot more sophistication and precision. There are different types of flow meters designed to measure the flow in different ways. Some of the most common ones include positive displacement, differential pressure, velocity, and mass flow meters. Positive displacement flow meters, for instance, work like a water wheel in a stream. The fluid physically displaces components in the meter to measure its flow. This type is often used in hydraulic systems. Differential pressure flow meters, on the other hand, rely on a pressure drop to calculate the flow rate. They're commonly used in the oil and gas industry. Velocity flow meters, as the name suggests, measure the velocity of the fluid to determine its flow rate. These are often used in wastewater treatment plants. And then there are mass flow meters. These measure the mass flow rate of a fluid directly, rather than its volume, which is crucial in chemical reactions where the mass of the substances involved is important. Each of these flow meters has its specific uses and advantages, tailored to different applications, whether it's in the food and beverage industry, the oil and gas sector, or in chemical plants. So the next time you see a smoothly running pipeline, remember there's a flow meter working tirelessly behind the scenes. It's not just about getting from point A to point B, it's about understanding how much and how fast, and that's where flow meters come into play. Transmitters, the unsung heroes of the industrial world, convert physical quantities into signals. They are the linchpins of any control system, providing vital data to ensure that processes are running smoothly and efficiently. Let's take a moment to understand the magic of transmitters. These devices convert various physical parameters, such as pressure, temperature, and flow, into signals that can be read and interpreted by an instrument or control device. This is no small feat, as it involves intricate mechanisms and precise calibrations. For instance, imagine the workings of a pressure transmitter. When pressure is applied, a sensor within the transmitter detects this change. The sensor then converts this pressure into an electrical signal, which is sent to a control system. The control system interprets this signal and makes necessary adjustments to maintain optimal operating conditions. This unobtrusive process happens constantly, ensuring that everything from your car's tire pressure to a high-pressure industrial boiler operates safely and efficiently. Temperature transmitters work in a similar fashion. They convert the temperature of a specific environment into a signal that can be read by a control system. This information is crucial in a variety of industries, including food processing, where maintaining accurate temperature is key to ensuring the quality and safety of products. Level transmitters, on the other hand, monitor the level of liquids or solids in a container. They provide critical information for industries such as oil and gas, where maintaining appropriate levels can mean the difference between smooth operations and a potential disaster. Moreover, transmitters play a crucial role in remote sensing and control. They enable us to monitor and control processes from a distance, ensuring safety and efficiency and reducing the need for constant human intervention. In conclusion, these devices are more than just industrial equipment. They are the eyes and ears of our control systems, constantly monitoring and adjusting to ensure that everything runs smoothly. Transmitters truly are the silent pillars of any process-oriented industry. Valves, the regulators of flow, ensuring everything runs smoothly and safely. In the world of industrial processes and systems, these small yet critical components play a crucial role. They are the traffic lights of the system, guiding and controlling the flow of fluids to ensure safety and optimize performance. Let's start with control valves. These are the primary regulators in any system that involve the flow of fluids. How do they work? By varying the size of the flow passage based on signals from process controllers. It's like adjusting the tap to control the flow of water. The control valve does this automatically, based on the readings it gets from the system. It's the fine-tuner that ensures everything is running at the optimal level. But control valves aren't the only type of valves out there. There are safety valves, check valves, and shutoff valves, each with their unique roles. Safety valves, for instance, act as a fail-safe. If pressure builds up to dangerous levels, these valves open up to release the excess. They're like the safety valves on a pressure cooker. Then we have check valves. These are one-way streets, allowing flow in one direction and preventing backflow. This is crucial in many systems, where reversing the flow could cause damage or contamination. Next, we have shutoff valves. They are the full stops in the system, completely blocking the flow when needed. They are used during maintenance or in emergencies when you need to stop the flow immediately. Each of these valves, though small and often overlooked, play an essential role in keeping our industrial processes running smoothly and safely. They regulate, they control, they protect. Without them, our systems would be chaotic and potentially hazardous. So, the next time you see a valve, remember that it's more than just a piece of metal. It's a critical component that keeps everything in check. Valves, small but mighty, keep our industrial processes safe and efficient. So, how do these devices work together to keep industries functioning seamlessly? We've taken a deep dive into the world of instrumentation devices, exploring their individual functions and collective importance in industrial processes. Let's take a moment to recap and appreciate the symphony of these vital components. We started with flow meters, the devices that measure the flow rate of liquids and gases. They're the gatekeepers, ensuring the right amount of fluid is delivered where it's needed. Without accurate flow rates, processes could go haywire, potentially resulting in costly and hazardous scenarios. Then we discussed transmitters, the communication link between the control system and the process. They convert physical quantities like temperature, pressure, and flow into electrical signals, providing real-time data that drives decision-making. Transmitters are like the eyes and ears of a process, keeping a diligent watch and relaying critical information back to the control system. Next, we delved into the world of control and other valves. These devices regulate the flow of fluids by opening, closing, or partially obstructing passageways. They're the decision makers, responding to the data provided by transmitters and adjusting the process accordingly. They're the hands that manipulate the process, ensuring it operates within safe and efficient parameters. We also touched on the significance of calibration. This process ensures these devices are working accurately and efficiently. Without regular calibration, the accuracy of these devices could drift, leading to inefficiencies or even safety concerns. From offshore oil rigs to onshore manufacturing plants, these devices are a testament to human ingenuity and the pursuit of efficiency and safety. They work in harmony, each playing their part in the grand orchestra of industrial processes. Their interdependence is key. A flow meter, a transmitter, and a valve may seem simple in isolation, but together they form complex networks that power our industries, from energy production to pharmaceutical manufacturing. From the flow of liquids to the regulation of pressure, these devices are the unsung heroes of our industrial world, working tirelessly to keep processes running smoothly and safely.